Okay, so today we're going to talk about phase changes. And phase changes are changes of state, okay? And not like the United States or states around the world, like countries, but like states or state of matter. State of matter, okay? States of matter are changing. So I'm going to draw a few pictures that will look pretty familiar to us. 1, 2, 3. Okay. So here are the phase changes that we're going to know for this class. So we have the solid state, right? And in the solid state, we've got particles. And those particles are stuck within a rigid structure. And they can vibrate in place. So we draw these vibration lines, but they're not switching spots with each other. They're like people in a movie theater, okay? They're stuck in their spots. And one defining characteristic of a solid is that, I mean, just like this marker, right? Any solid holds its shape. But solids can turn into liquids. And they do that through a process called melting. So when solids turn into liquids, they gain energy. So solid particles gain energy and break free of interparticle attractions that cause rigidity, okay? So a rigid structure. So this rigid structure goes away. And now the particles enter the liquid phase, and they're able to move around a little bit, so they kind of tumble past each other and they switch spots with one another, and you know, this guy goes one way, the other guy goes this way, this guy is going, you know, this guy's going nowhere, let's say. So these particles move around past each other, they slip, slide, tumble around near each other. So these guys are sort of like a crowd, right? A crowded, let's say a crowded dance floor, okay? So people on the dance floor moving by each other, or like you could be talking about like this is kind of like Disneyland, right? They're sort of moving around past each other in a big old crowd. They're not stuck together like they are in a movie theater, all right? So we've got these liquid particles moving around each other, and they're able to break free of these interparticle attractions that cause their rigidity, okay? So they're not stuck in place, but they're still attracted to each other. They're still cohering to one another. So turns out that if you add a little bit more heat or a little bit more energy, you get a process called evaporation. So liquid particles gain energy and break free of all interparticle attraction and enter the gas phase. They enter the gas phase, okay? So when liquid particles gain some more energy, they can eventually gain enough energy to break free of all interparticle attractions and enter the gas phase. So when they're in the gas phase, of course, they're just flying around.
Wait, what is that saying between the and
The gas phase.
No, right there. Liquid particles gain energy and break down.
Break free of all interparticle attractions. Okay? Good question, Elijah. All right. So they go into the gas phase. So now we're going to reverse things. So going from the gas phase back to the liquid phase is a process called condensation. Okay? And in this process, gas particles, so what's the reverse of gaining energy? Losing energy. So these gas particles lose energy and return to the liquid phase. Okay? So once these gas particles have lost enough energy, they've gotten into a situation in which their interparticle attractive forces start to dominate their interaction. So they're not just bouncing off of each other and bouncing off the sides of their container anymore. They're colliding with each other, but they're sticking, and they're forming a liquid. And this word condensation has a relationship, of course, to the word condense. So if something condenses, right, is something that condenses getting bigger, or is it getting smaller? Something that condenses. Somebody's whispering it, we need to hear it out loud. If you condense, you're getting bigger or you're getting smaller? Smaller, Fatima, good. So look, this sample of gas over here is represented as occupying how much of the container? How much of the volume of the container does this gas occupy?
All of it, right?
All of the container, good Elijah. But then, after it condenses back into a liquid, how much of the container does it occupy?
Portion.
Just a portion, right? So this word condensation indicates to us that the gas is actually condensing physically. It's occupying less volume in the liquid state than it does in the gas state. And we've seen this before. Okay, we're familiar with this concept. Now, when a solid gains energy, its particles melt to form a liquid. So the reverse of that would be freezing. And during freezing, what happens? What happens? Are these liquid particles gaining energy, or are they losing energy? Good. So liquid particles lose energy and adopt a rigid structure. Okay? A rigid structure. That's what's happening. The last thing that I want you to see is a term that's already familiar to you. So that term is called boiling. And boiling, okay, boiling occurs when the vapor pressure, and I'll explain what that is in a minute, okay, that is the pressure exerted by liquid particles entering the gas phase So boiling occurs when the vapor pressure of a liquid equals the atmospheric pressure around or above the liquid. Okay? So we may end up discussing vapor pressure a little more later, but essentially, when a liquid is even at room temperature, right? So, like if I go outside and let's say there's some water on the sidewalk. If it doesn't rain between now and tomorrow, do I expect that same water to be there on the sidewalk?
Nope.
No. That water is going to evaporate. Why? Because these liquid particles are bumping around into each other. And on average, some of them, a small number, are going to get just like hit so many times so hard just because of this is random collision here, that they'll enter the gas phase. Well, if there's no container to hold them in, they just go into the gas phase. So puddles that are on the sidewalk just go ahead and evaporate. But that lets us understand that this liquid exerts some vapor pressure. And that vapor pressure is the pressure of those molecules that are entering, or those particles I should say, because we really haven't talked about molecules yet. Those particles that are entering the gas phase. Well, if you add enough heat to a sample of a liquid, eventually the pressure from the particles entering the gas phase gets so high that it equals the atmospheric pressure. And at that time, boiling occurs. Alright, so that's just a nice little formal definition for you to have in your notes, because boiling is a process that we might be exposed to on a daily basis, right? Like how many of us make coffee, or how many of us make pasta, or how many of us have parents who make coffee in the morning, right?
Coffee's legalized.
Right? Boiling, 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 okay?
Yeah.
So, any questions? Alright, thank you, scholars.